Understanding the Kinetic Drive Vehicle Propulsion System, Part 1. Hi, my name is Ray Sherry, and some years back I invented and patented a vehicle propulsion system using a flywheel as the prime mover. You're probably saying to yourself, that's nice, but why should I care and what's in it for me? Basically, if you are into performance vehicles, saving money, or getting on the ground floor of a paradigm shift in transportation, you may want to pay attention. Previous failed attempts to incorporate a flywheel into vehicles used the flywheel only as an energy storage device. This inefficient configuration required generators and motors, along with a myriad of other components, necessary to support the multiple energy conversions between mechanical and electrical. Also, with this previous method, maximum energy transfer was limited by the power handling capability of these components. This same inefficient concept is now used in electric vehicles and called regenerative braking, where the primary difference is a battery system is used instead of a flywheel. With only about a 5% increase of EV range and the charging rate of batteries significantly slower than a flywheel, this will definitely be a topic for future discussions. The difference with our technology is we developed a high-efficiency, direct, mechanical-to-mechanical energy transfer system, both to and from the flywheel, during braking and acceleration respectively. Obviously, when there are no energy conversions, there are no energy conversion losses. Using our direct mechanical energy transfer method, doubling your fuel mileage while drastically increasing acceleration and torque, or fulfilling your dream of building a budget 8-second street legal drag car is possible. The power and torque delivered by this system is well beyond any other practical method and works in tandem with both current and future prime movers. These concepts will become more apparent as you gain understanding. This technology was conceived on the notion that it would replace the requirement for a vehicle to need a large, inefficient engine just for a few seconds of acceleration. It is well known that once your vehicle is up to cruising speed, very little power is needed to maintain velocity. With a kinetic drive installed, your engine will only need to run intermittently to spin up the flywheel, leaving the flywheel to do all the heavy lifting, such as acceleration and braking, thus reducing fuel consumption considerably. Think of it like winding a clock. You only have to add energy to the spring when needed, otherwise the exciter, that being you, just walks away. There's no engine more efficient than one that's not running while you're still moving. Don't worry if you're not fully grasping what I'm laying down, because we will continue to provide examples and comparisons. Our system, besides being completely different from any other vehicle propulsion system, has a host of advanced features we will discuss in the future. Those of you that are starting to get it, I imagine the wheels in your head are already turning. It's just not every day you hear about a practical, more powerful and efficient alternative to vehicle propulsion that actually works, is affordable and makes total sense. For me, performance is a passion, and if this technology was not hotter than a solar storm in July, I frankly would not be working on it. Before we start to dig in on the breakdown of our first topic, I just wanted you to let you know potential applications of this technology range from an electric bicycle to a freight train. In other words, the market is both wide and deep. If it's on the road, it could benefit from this technology. Don't forget to send us your email address if you haven't done this already. Our weekly mailing will be focused on answering questions, getting updates, and a more in-depth analysis on some topics. We need to build a community for this solution, so let's get started. Okay, let's get started. First, the basics. Kinetic energy is the use of stored energy. Our system captures and stores energy from an exciter. This stored energy is used to propel a vehicle. The energy used to excite the kinetic drive can come from several sources. Here are a few examples: a gas or diesel engine, an electric motor, or the vehicle's momentum during deceleration. Some of you may require additional understanding of the basic physics behind the kinetic drive. If so, just ask. Let's put together some real values for our technical and NHRA folks. We will compare two examples and see if you can notice an interesting paradox from a drag racer's point of view. The first system uses a 300-pound flywheel consisting of run-of-the-mill 110K plate steel. The second will use the same steel but weigh an additional 200 pounds for a 500-pound flywheel. We will use a base vehicle weight of 3,000 pounds before we add the weight of the flywheel. So the first vehicle weighs 3,300 pounds and the second vehicle weighs 3,500 pounds. Running the numbers with a safety factor of 2x for our steel and only using the excited flywheel's energy to accelerate the vehicles, in other words, the engine is shut off during the run. The first vehicle can accelerate to about 105 miles per hour before the flywheel is exhausted, and the second vehicle can accelerate to about 135 miles per hour before the flywheel is exhausted. The energy in the first vehicle's flywheel would be about 1.8 million joules, or 2,400 horsepower second when fully excited, and the second vehicle's flywheel energy would be about 3 million joules, or 4,000 horsepower second. If each car had a 200 horsepower engine or electric motor to excite the flywheel, it would take the first car only about 12 seconds to energize, and the second car would take about 20 seconds. Well less than any burnout or staging time at your local drag strip or streetlight. Finally, the paradox: using the same size engine or motor, the heavier car in this example would outperform the lighter one. This is just not the way it's supposed to work. As we explore the kinetic drive system, you will find it's going to change plenty of what you thought was gospel. That's enough for now. Please keep an open mind. I understand change is not always easy or welcome, but let's all stay positive. Please subscribe to receive updates and notifications as we continue to explore the kinetic drive system.